Hey everyone, welcome back to another video. We are going to build up the unit rate of vibrated reinforced concrete class 20 per cubic meter. So the sum that we shall calculate is, using the data given, build up a unit rate for vibrated reinforced concrete class 20. Class 20, that is 1:3:4 ratio per cubic meter. The data: hire rate of the mixer is 10,000 shillings per day. Cycle time of the mixer is 5 minutes. Mixer efficiency is 90%. Drum capacity is 0.2 meter cubic. Maintenance and repair is 1 hour per day, and each day is 50 shillings. Diesel is 5 liters per hour. Each liter of diesel is 110 shillings. Lubricating oil and grease is 30%. Diesel of density of sand is 1600 kilograms per meter cubic. Density of cement 1440 kilograms per meter cubic. Density of ballast is 1500 kilograms per meter cubic. Then we have the cost of cement is 700 shillings per bag. The bag is 50 kg. Sand, the cost is 1800 shillings per ton, and ballast 1500 shillings per ton. Then you're told to make reasonable assumptions for information not given. When we are calculating the unit rate of vibrated reinforced concrete, the unit rate per cubic meter will be material cost, cost of buying materials, plus mixing cost for the laborers and the plants we shall use for mixing, plus transport cost, plus laying cost, laying the concrete, plus overheads and profits. Overheads, they are those indirect costs relating to the project, and the profit is that benefit that the contractor will get. So we start with the material cost. How much will we spend on the materials? How do we calculate this? We are told the concrete vibrated reinforced concrete class 20 is ratio 1:2:4. If it's ratio 1:2:4, meaning 1 is for cement, 2 for sand, 4 for ballast. So to calculate the cost for the materials, we need to know their amounts. To know their amounts, we shall use, to know the mass of cement, we shall use mass is equals to density times volume. So it shall be taken, cement is 1 volume. 1 volume of cement, we shall take 1 volume of cement, 2 volumes of sand, and 4 volumes of ballast. Then the total cost we shall use to buy all these 7 volumes, we shall divide by 7 to get the volume of 1 volume mixer. So I repeat that, we shall take the cost of 1 volume of cement, 2 volumes of sand, 4 volumes of ballast. Then the total cost we shall incur, we shall divide by the 7 volumes to get the average cost per volume of the mixer. So for cement, we shall take 1 volume, so we shall take density of cement is 1440 times 1. Then we get the mass of the cement. We divide by 50 to get how many bags of cement. Then we multiply by 700, which is the cost of cement per bag. We get 20,160. For sand, it's 2 volumes of sand. Density of sand is 1600 times 1. It should be 1600 times, okay, we are finding the mass of sand, so it shall be 1600 times 2 divided by 1000, because 1600 density times volume 2, then you divide by 1000 to get the number of tons, then you multiply by 1800 shillings. You get cost of sand for 2 volumes will be 76.50. For ballast, it's 4 volumes. So we take the density of ballast 1500 times 4 volumes of ballast. We divide by 1000 to get number of tons. Then the cost of per ton, we get 9000. So the total cost of cement, sand, and ballast will be 20,160 plus 5760 plus 9000. We get 34,920. That is the cost of buying cement, sand, and ballast for the 7 volumes. Then we shall add the shrinkage. When we are doing the buying the materials, we should account for shrinkage, because when we add the cement, sand, and ballast, it will shrink because of the air spaces. So we shall add 45% of the materials for shrinkage. And because now we know the cost of the materials, which is 34,920, we shall take 45% more. So it shall be 145% of 34,920. We shall get 56,634. So the total volume for the 7 volumes, the total cost for the 7 volumes will be 56,34. So we divide by 7 to get the cost of 1 volume of the average mixer. So the cost of 1 volume of the mixer will be 7,233.43. We have found the material cost. Now we shall go to the mixing cost. The mixing cost, we shall use a mixer. The mixer, we are told the cycle time of the mixer is 5 minutes and the mixer efficiency is 10%. Drum capacity is 0.2 meter cubic. Drum capacity means whenever we are mixing, we shall mix for every mix cycle, we shall have concrete of this volume. The cycle time is that time that the mixer will take to rotate to mix the concrete will be 5 minutes. So that 5 minutes it will deliver this volume with this efficiency. Because it's not 100% efficient, we shall take, to get the number of cycles, we shall take 90% of number of cycles. So let's get going. The mixing cost will be, we find the number of cycles per hour. How many minutes do we have in 1 hour? 60. The cycle time of a mixer, 5. So how many cycles do we have in 1 hour? It's 60 divided by 5, 12 cycles. Then it is 90% efficient. So it will not go for the full 12 cycles. How many cycles will it go? 90% of 12. We get 10.8 cycles per hour. So the output per hour, the total output of concrete per hour will be number of cycles per hour times the output per hour. So it will be 10.8 times 0.2. We get 2.16 meter cubic. So 2.1 meter cubic will be the output of concrete per hour. So we continue. The owning and running cost per hour, we shall use 8 hours a day as working hours. 1 day equals 8 working hours. So we shall now calculate the cost of the mixer per hour. Now that we know the total output per hour, we can be able to calculate how much it will cost us to have the mixer per hour. The higher rate in the question, we are told higher rate of mixer is 10,000 shillings per day. So we shall take, we want to find the higher rate per hour. So it shall be 10,000 divided by 8 hours a day. We get 1250 shillings per hour. We go to diesel. Diesel, we are told we shall use 5 liters per hour, each 110. So we are already told we shall use 5 liters, each 110 per hour. And we want diesel per hour. So it's 5 times 110. We get 550. The next one is oil and grease. In the question, we are told that lubricating oil and grease is 30%. So oil and grease will be, it should be, this one is 30 shillings. 30 shillings per hour. So oil and grease will be 30 shillings in 1 hour. So it will be 30 shillings. Maintenance and repair per hour, it shall be, in the question is maintenance and repair per hour, and maintenance and repair is 1 hour per day, and each goes for 50 shillings. So we shall say 1 hour out of the 8 hours, and it costs 50 shillings for the whole day. So it shall be 50 divided by 8. We shall use 6 shillings and 25 cents to repair and maintain the machine for an hour. We go to labor of mixing. Labor of mixing, we are not given any information about the mixing labor. So when we shall be using, the mixing labor we were not given in this question. So we shall assume it shall take 8 laborers, unskilled laborers, to do the work. So each laborers. Then each laborer, how much do we pay him? 400 shillings per day. How many hours per day? 8 hours. So it shall be 8 times 400 over 8. We get the total is 400 shillings per hour. So the total cost of the mixer is the cost of the hire rate per hour, that is 12.50, plus diesel per hour 5.50, plus oil and grease per hour 30, plus maintenance and repair per hour 6.25, plus labor per hour 400. So the total cost will be 2,236 shillings and 25 cents. So if the cost of the mixer per hour is 2,236 shillings and 25 cents to mix 2.16 meter cubic, how much will it cost to mix 1 meter cubic? So it shall be 2,236.25 we divide by 2.16, we get 1,335.30. That will be the cost for mixing 1 cubic meter of vibrated reinforced concrete. So we shall continue to the transport cost per meter cubic. Assume 2 hours was used to transport 1 meter cubic, and the transportation cost was, assume 2 hours was used by 1 laborer to transport the concrete. How much will it cost? Assume 2 hours was used by a laborer to transport the 1 meter cubic of concrete. So we are paying the laborer 4,400 shillings per day for 8 hours. So for every hour we are paying him 50 shillings, and he will use 2 hours. So how much will we pay him? So it will be 400 divided by 8, 50. 50 times 2. So it should be 100, because this one, we are finding the cost for per meter cubed. Our intention is to find the cost per meter cubed in everything. We found the cost of the materials per meter cubed here. Then we found the cost of mixing cost per meter cubed here. Then we have found the total cost of transporting 1 meter cubed. Now we go to the laying cost. Assume 1 hour was used to lay with the 1 meter cubed using a gun size of 1:1, skilled and unskilled. So how much will it cost us? The skilled laborer, we are paying him 800, then unskilled 400. So we shall pay them 800 plus 400 the whole day, divided by 8 hours, so that you get the cost per hour for both. It shall be 150. 800 plus 400, 1200 divided by 8, 150. So to get the cost of vibrated reinforced concrete per meter cubed, we shall take the material cost per meter cubed is 7,233.43. Mixing cost is 1,035.30. Transport cost is 100. Laying cost is 150. Total cost of all this is 8,518.73. Then we add the profit and overhead, say 20%. 20% of this one. So 120% of this shall be 10,703.75. So that will be the unit rate for vibrated concrete per meter cubed. So in case you have any question, write it in the comment section. If you have liked this video, kindly give it like it or give it a thumbs up. Kindly subscribe to this channel and even hit the notification bell so that you can be aware whenever I post such content. So thanks for watching. Let's meet next time.